By the way, that three-dimensional grapher, this grapher right here, I put a link. This is a GeoGebra 3D grapher. You need to learn how to do the algebra, because when you take the SAT, you're not going to have access to a GeoGebra 3D calculator. But I want you, when you're doing your homework, crank through, do the algebra, plug it into this calculator. The link is online in Schoology. Plug the equations and plug in your solution, and it should intersect like this one does. Okay? Anyways, let's get started. So it says there is a unique vertical parabola passing through any three non-collinear, that means they're not on the same line, points in the coordinate plane, provided that no two of the points have the same x-coordinate. Find the vertical parabola that passes through the points 2, 1, -1, 4, and -2, 3. So we are solving systems with three variables. So A represents, remember, this looks like, so let me kind of justify. It says the general form of the vertical parabola is a quadratic equation, ax squared plus bx plus c. In order to find the equation of the parabola, we must identify the values of a, the values of b, and the values of c. Since each point lies on the parabola, substituting the coordinates for each of the following into the general equation produces a different equation. So here's one thing I need you to know. When it comes to systems, you need the same, write this down in your notes, same number of equations for the same number of variables.
Of what?
Variables. And sometimes you'll hear teachers call those unknowns. So in other words, I don't know what A is. I don't know what B is. Whoops, I skipped ahead of myself there. I don't know what A is. I got to solve for A. I don't know what B is, so I've got to solve for B. I don't know what C is. I have three variables that I don't know, so I'm going to need three equations to solve that. Now, you haven't picked up on this, but on our first example, we had x, y, z, three variables. How many equations did we have to solve that? 3. On the previous section, we had two variables, x and y. How many equations did we have on every one of those problems? 2. Now, if I gave you 4 variables, how many equations do you think you would need? 4. Okay, that's how you solve it. And what you do is you could do substitution, elimination. In college, you'll learn how to do matrix operations, but it's basically the same thing. It's just a shortcut. But basically, you're going to eliminate one variable at a time till you get down to 1, solve for that variable, and then work backwards and plug them in. So let's start this process. So I have a bunch of equations here, and what they're going to do is I know that these are all x values and these are y values. This is an x value, this is a y value. This is an x value, this is a y value. Now, if it helps, you could call this x1, y1. You could call this x2, y2. You could call this x3, y3. So I just need to know that when I plug these in, that they match what I want them to match. In other words, on this first one, I plug in a 2 for x here, and then I plug in a 1 for y here, right? Because these are going to be y equals a times x squared plus bx plus c. Now for the next one, I have my y value of 4. What does that correspond to? An x input value of -1. On the third equation, when x equals -2, my overall y value should be 3. So I'm just plugging in the x's and y's, doing a little bit of math, and I get the following equation. 1 equals 4a plus 2b plus c 4 equals A minus B plus C, and 3 equals 4A minus 2B plus C. So mathematically, I'm going to point out a couple of things. Notice that all of these have a C all by their lonesome. That's going to be very useful. Okay, so let's start with that. So if I want, I could take equation 1, right? This is equation 1. If I take equation 1 and I solve for C, I'm just going to subtract these things and move them to the other side of the equal sign. So that becomes C is equal to 4. Actually, no, wait. Yeah, let me back up for a second. I'm going to do 2 because I think that might be a little easier. So I'm going to take 2, which is 4 is equal to A minus B plus C. So this is equation number 2. And I'm going to solve for C. So that means I'm going to add B and subtract A from both sides. So over here I'm going to subtract A, add B. So this line becomes 4 minus A plus B equals C. That's equation number 2. Okay? Now I'm going to do the same thing. So now that I have that, that equals C. So now if I take equation 1, which is, I'm going to write in equation 1, it's 1 equals 4 times A plus 2 times B plus C. But I'm going to substitute in this right here because it's equal to C. So I'm going to say 4 minus A plus B. Now, truth be told, because it's a positive, I don't even really need the parentheses. Right? I could just leave it written like this. That plus sign doesn't change anything. Right? So now I have an equation with a bunch of A's and a bunch of B's. Let's combine like terms. So I have 4A here minus an A. That's 3A. Okay. I have positive 2B plus another B. That's a positive 3B. Now, if I'm smart, I'm going to take this 4 and I'm going to subtract 4 here, and I'm going to subtract 4 here. When I do that, these 4's cancel and I get negative 3 over here. All right? So that whole thing becomes negative 3 is equal to 3A plus B. So this is technically equation 1, sort of, slightly varied. Now, the reason I'm labeling the equations is I don't want to get confused with what I plugged in and what I haven't. Now I need, which equation have I not used yet? 3. So over here somewhere, I'm going to come in and I'm going to say, all right, let's do something with equation 3. Well, equation 3 is equal to 4 times A minus 2B plus C. But guess what I'm going to write in for C? The same thing. I'm going to write in 4 minus A plus B. This is equation 1 set equal to C, right? So I'm plugging that in for C. Again, same thing as before. I'm going to combine like terms. I have 4A minus A is 3A. I'm going to combine like terms, and I'm going to say negative 2B plus B is minus 1B. I'm also going to subtract 4 from both sides. Subtract 4 here, subtract 4 here. And that leaves me with equals negative 1. This is equation number 3, slightly varied. Okay? So I have two different equations. There's a couple of approaches I could take, but basically now, if you notice, there's no more C's. I've gotten rid of all the C's. So there's a couple ways I could do this. I could solve for B, I could solve for A, there's all kinds of stuff I could do. What I'm going to do is I notice that this one has a B all by itself. So I'm going to add B to this side. I'm going to add B to this side. That gives me B minus 1 is equal to 3A. Then I'm going to add 1 to this side, add 1 to this side, and I get B is equal to 3A plus 1. That's still equation 3. Over here on equation 2, or I'm sorry, actually equation 1, I'm going to take minus 3 equals 3 times A plus 3, but over here, I have this equation that I've solved for B, right? So I'm going to take this whole thing, actually it's just this part. I'm going to take this whole thing and plug that in for my B over here. So over here, I'm going to say 3 times 3A plus 1. Okay? Now notice I have a bunch of numbers and the letter A. That's good. So I'm going to distribute this 3 through. 3 times 3A is a positive 3, or not 3, 9A. Positive 3 times positive 1 is a positive 3. And then all this other stuff gets written down. If I combine like terms, I get 12A plus 3 is equal to negative 3. Subtract 3 from both sides. Okay? And then I get negative 6 is equal to 12A. Divide by 12. And I get A. I'm running out of room, but A equals negative 1 over 2. Okay? That's it. A equals negative 2. Or I mean, negative 1/2. Now, if I want to find B, I just have to find an equation that's solved for B. Well, this one's solved for B, so I could say B is equal to 3 times A, which is negative 1/2, plus 1. That's negative 3/2 over 2 plus 1, which is actually equal to negative 1/2. Now, I'm doing this in my head. If you at any point in time are not sure of what to do, you can always do it in your calculator. What did it say? 3 times 1/2 plus negative 1/2 plus 1. I could say 3 times, put in my fraction, negative 1 over 2 plus 1. Negative 1/2. Okay? So that's legit. So now I know what B is. B is negative 1/2, right? So we'll say B equals negative 1/2. Now I just need one equation that is set equal to C and plug these in. Well, somewhere over here, I remember solving for C way at the beginning, right? This one, right? So for this one, this is kind of cool. I'm going to copy it down here because I got a little bit of room. I've got 4 minus A plus B. 4 minus A plus B equals C. Yeah? So now watch this. 4 minus 1/2 plus negative 1/2. 4 minus 1/2 equals plus 1, negative 1/2 equals C. Well, this becomes a positive 1/2, right? And when you subtract 1/2 from 1/2, that becomes 0. 0 plus 4 is just 4. So C equals 4. Now remember, the equation was we got to find ax squared plus bx plus c. So to solve this, what is the equation? Well, the equation, and I'll zoom out so you can write this down, should be y equals ax squared plus bx plus c. So we just plug that in. So a was negative 1/2 x squared plus b, which was also negative 1/2 times x, plus c, which was positive 4. Okay? So now, in order, and I'll zoom this out so you guys can get it all in and write it down in your notes. While you're writing that down, I want you to think about this. We did a bunch of math. How do I know the math is right? How do we know the math is right? Is there something I could do to double check it? I could graph it. And if I graph it, what does that do? Bingo. The student said it shows us the points. They gave us these 3 points. So if I graph this equation, these 3 points should be on the line. So I'm just going to give you another second to write that down. I'm going to open up my calculator and I'm going to move it off the screen. But I'll go ahead and graph this. And then when you get a chance, you guys should probably do the same, graph this. So I'm going to put it in the calculator. Do you have this written down? Hey, you two, over there, chit-chatting. Plug this in the calculator if you're done writing it down. So then I'm going to, in the calculator, I'm going to start plugging this in. You guys should do the same, and I'll put it on the screen. I'm just leaving this part of the screen available so you guys can finish writing down all the notes, because I kind of went fast, but that's okay. There'll be one like this on the test, yes. Absolutely. All right, do you guys have that copied down yet or no? All right. So I'm almost done. I'm going to move this back over here so you guys can see it. So the only thing I'm doing is plugging in the equation, okay? So it's negative 1/2 x squared minus 1 over 2. Notice that I put a negative 1 here, a negative symbol here, and a minus symbol here. If you make a mistake and put the wrong symbol, you'll get a syntax error. That just means you have a minus sign when you should have a negative, or vice versa. Okay. Anyways, x plus 4, I think, right? Isn't that what it was? I'm just going to do a standard zoom. So this is our parabola. Now, let me make this a little smaller so you guys can see it. Now, if I did my math right, these points, let me zoom in so I can see the points here. These points should exist on that curve, right? So let's go in there and see. So if I hit trace, remember when you hit trace, you just have to hit the x value. So when I plug in x equals 2, what do I expect the y value to be? When x equals 2, the y value should be 1, right? So when I come over here and I hit enter, guess what? The y value is 1. When I enter in negative 1, the y value should be 4. It is. And then when I hit negative 2, the y value should be 3. So all 3 points exist on that parabola. So we did it. That's correct. Does that make sense? Let me zoom in and Now, another way you could do this too is to check the table of values. So if you hit second table, our lowest value is -2. So we go from -2 to 2. Let me zoom in on that. So we got these values here. So when I've done all the math, this will probably be a little greeny, but as you can see, those points exist on the line, right? -2, comma 3 exist on the line. Also, -1, comma 4. And then what was the other one? 2, comma 1, right? Two comma 1. Those all exist on the line. Yes. Yep. Any questions on that? All right. Let me zoom back out and